Chapter 3 is a collection of a whole bunch of different tools. Some are statistical, some are financial, and some are analytical. So I hope you'll enjoy this particular chapter. It includes many things we'll use in this course and I believe will be helpful throughout your career. So the comic on the right says, 73% of statistics are made up on the spot. I sometimes think about that because I hear reports that sound a little implausible. It's supposed to be like real data, but it sounds a little bit implausible, like this guy. Our first topic is basic statistical concepts. Again, you've probably seen them before, but it's good to do them one more time. Then we'll do some performance improvement tools, and this is just a selection of one slide per tool, just to familiarize yourself with some pretty powerful things that we see in industry. The third topic is overhead allocation. It's an important topic for all companies because we want to measure performance not just at the company level, but at the department and division level. And to do so, we need to allocate overhead. Fourth is we'll look at financial relationships between different aspects of the reports, and we'll see how these work as far as company versus department versus industry. Then we'll cover expected values and decision trees. You may have seen this before. If not, it's a powerful tool that we should have in our quiver. And finally, look at quantifying risk, ways for us to, when we finish the model, be able to show our bosses that we've been thorough in our consideration of what else may occur other than our expected case. Here's a refresher of basic statistical concepts. Quartile. That means you array all the data from top to bottom, and then you take a quarter at a time. Quartile is basically 25%. That's how you remember that. So we'll have 4 quartiles within a data set, but they're not in a random order. They're rank ordered from top to bottom. Then we have decile, which is very similar to quartile, but instead of quarter or 25%, it's 10%. So we have 10 deciles. The third topic is Pareto analysis. Similar to this, it's the famous 80-20 rule. So we array the data, and we see if we get to 80% with 20% of the data points. And this shows the accumulation or the consolidation of the major activity among a few of the items not evenly distributed. Fourth is the statistical measure of a mean. This is a straight average. It's an arithmetic average of the data points. Fifth is median. When we array the numbers in order, what is the midpoint right in the center of the entire distribution? And sixth is a standard deviation, where we make the assumption that our distribution will mirror the standard deviation. And if we allow ourselves that one assumption, then we can make some very powerful assumptions like how wide a range might we expect as far as capturing a number, the magic number for one standard deviation of 68%. So one standard deviation plus or minus from the mean will capture 68% of the observations. So these are very powerful and basic statistical measures. We're going to use an example just to see if you can still remember how to do this. Of course, I'll be doing it, you'll be watching, but I'm going to do it in Excel, and that should trigger, hopefully, fond memories about statistics. And we do them in a slightly different order because of the way the spreadsheet is set up, but we'll hop into Excel at this point. All right, here's the data in Excel, and it's just an example with an array of different product numbers. Then we have for those products the unit sales for each product, along with the year-end quantity in inventory. So we have sales during the year and then an endpoint at the end of the fiscal year. Then we have the unit cost, and the unit cost is how we record inventory. So the number of units times the unit cost equals the extended or the inventory carrying cost. And that's what we see here in the buff colored column. Then we have that as a percent, just as a calculation to save us a little bit of work. And next to that is a day sales and inventory. Gives us a feel for how fast these items turn in inventory. The smaller the number, the fewer the days, the faster the sale. The bigger the number, the slower the sales, and that's not good. And on the far right, the column is cost of goods sold, which is simply taking the number of units sold during the entire year times the unit cost at the end of the year. So it's an approximation of unit cost. It's an approximation because the cost for the inventory may vary from time to time. But this just gives us a feel for the amount of volume that we sold of particular products. So we see here that we have a fair number of data points, not a lot in real life terms, but enough for us to do some good work as far as some analysis. I'll go to the bottom now to do the measures. So first up is a median. Median, as I mentioned, is the easiest one of all, and it's simply the straight average. We could just put in equals average, So the average is 1,866. So that's the average value in the inventory. Next, we'll do a sort. For the sort, we'll just shade the region we want to cover. And I'll shade the entire region of the data along with the header row. And then go to Data, Sort, and select the field I'm interested in, which is Extended Cost, which is the inventory balance that I mentioned, that kind of buff colored column. And we'll do it from high to low and say OK. So it's a pretty simple function, and you can just visually see that it worked. And the largest item in inventory is this unit 1015 with $14 million worth. And now we could do a few things. First, let's do median. Median, as you recall, is the midpoint. So I'm just going to shade any of the rows. And it does a count. You can see it perhaps on the bottom there. It is 40 rows of data. You'll also see it here as a count. Also the average there. All right, so we could have done it that way. I just did it by Excel formula. So if we have 40, the midpoint is around 20. So let's find the 20th value. So that is the 20th value. Now, when we have an even number like 40, the midpoint is actually not 20, it's not 21, it's in between 20 and 21. So to be precise, the median will be the average between these two rows right here. I'll just do it right here. So it's the 400 plus the 392, and you take that total and you simply divide by 2. So the median is 396. All right, next we'll calculate the standard deviation. STD, standard deviation. And here we have a sample. And we'll shade the region. Make sure we capture all the data points. Close friends and enter. And that number is 3,352,000. The interpretation is that there's a mean, and that mean is about $1 million. But the standard deviation that would capture 68% of the data points is plus or minus 3 million. So it's a pretty big range. And you can see why there's some very large values inside of our data set. Next, we'll do the Pareto. For that, we'll need cumulative numbers. So I'll put cumulative and then the percent of the cumulative. And we're just going to keep a running tally where we go from the biggest to the smallest and see how long it takes us to get to 80%. So the first figure is we'll have just that number because cumulative is just that one number anyway. But the second one gets a little more interesting. It's the prior plus the new data point, and we'll just continue that down. I can copy that now all the way down. So the next one we'll do is calculate the cumulative percentage of the total. The first number is 14, and we're going to divide that by the number on the very bottom, this number. But this needs to be an absolute reference because it won't change. That is the total. It will not move down as we go down. So you hit F4, which puts dollar signs in front of the column and the row designations, and you can see it right here, $E and $93. Notice that the numerator, I-52, we're leaving alone as a relative. So as we move down, it'll move. As we move down, it'll increment down to row 54, 55, etc. And yet the next factor, the denominator, will not move. So we'll do this. Oh, there's an interesting number right there. 20% of the entire inventory value is held in one product number. All right, we'll just continue this down. And we'll see that it keeps rising. So we see that we get to 80% right there. So I'll just kind of highlight this row. So we can say that 80% of the value is comprised of these items here. And when I just shade it, I can see that the total number of columns is 8. 8 out of 40. 20% of the inventory comprises or constitutes 80% of the value. So this, by construction, I'm supposed from the author of the book, is the 80-20 rule, where 20% of the items, again ranked ordered, the top 20% of the items comprise 80% of the value of the entire inventory. So that's the Pareto. Normally it won't be so neat and tidy at 80-20. We'll see that kind of accumulation or aggregation in the larger selling items, but won't magically be 80-20. There's no rule that it has to be 80-20. Next is quartile. Quartile, since we have 40, we just create breaks. Every time there's a quarter of 40 or 10, there's a break. So we'll just do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that, and this is the first quartile. We can sum the inventory in that first quartile, and that's $65 million. Then we count the next batch of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there at row 72, well, that makes sense. Because the next quartile equals sum. So the next quartile is only $5 million. So again, we see that heavy concentration among the most popular items in our sales and our inventory. And the top quartile captures $65 million of value, which comprises 87% of the total value. The next quartile captures another 5.7 million, which is only an incremental 7.6. So we could do this for the other two quartiles. Obviously, we'd get to 100% of inventory. So that's quartile. And again, it's another way to view this heavy concentration inside the top few units. And deciles we're splitting by tens. Okay, so 10 would be 4 per, because 40 divided by 10 is 4. I won't bother doing that, but we would just count off 4, insert a row, do a total. Same routine. So that's some basic stats on mean, median, standard deviation, Pareto, quartile, decile.